Good morning, Sauhegan. It's April the 13th, and it really doesn't feel like a Monday. It feels like a Friday because it's rainy and icky out. I need my sun. But today what we're going to look at is solving or finding roots of polynomials that can be factored or undone. But to quickly review, let's just remind ourselves what that means. So when we're finding roots or solving, we want to remember that we want to know when our y value, or f of x, is equal to 0. And what that then is going to leave us with is that one or part of these factors, or all, could potentially be 0. So we've got negative 2x equals 0. We have x minus 23 equals 0. And this should be old hat. X plus 4 is 0. And x minus 32 is 0. So in this is the one that people always forget. So don't forget this one. We get x is 0. Over here we get x is 23. We get x is negative 4. And x is 32. Well, what if it's not already in factored form? What are we going to do then? Basically, we want to then set each factor equal to 0, or each, in this case, trinomial equal to 0, and then we're going to solve that. So some of you may naturally want to run to quadratic formula, but I would hope that at this point you would look at these and see that they're factorable, and that'll save you a lot of time. So I'm going to do our quick factor of these. We've got the shortcut, remembering that what two numbers multiply to positive 2 that add up to negative 3 are negative 2 and negative 1. So I get x is 1, or I get x is 2. We're going to do the same thing for this back group. We want factors of 18 that add up to positive 7. So 9 and 2. So negative 9 and positive 2 multiply to negative 18, but add to positive 7. So I get x is 9, or I get x is negative 2. And when here we can see we have our answers. Now, how would I know that I need to get 4 of them? Well, I want to go back and look up here. I have x squared times x squared, which is x to the 4th, so I should get 4 roots. Going back to the one before, we did have a double root here, so that's why we don't have 5 roots. We only have 4, because at x equals negative 4, oh, I screwed up, x equals negative 4, we have a double root. So now let's go down to the last two. The last two that we have, we can still set those factors equal to 0. Your inkling may be to grab that quadratic formula and try it, but these both can be undone. So remember, undoing saves us a ton of time. So the left-hand factor, the product of what number gives me negative 36 is going to be positive 6 and negative 6, and that'll eliminate that b term. Here I'm going to undo, so I'm going to subtract 9 from both sides. Over here I get x is negative 6, or x is 6. And if you looked at our video 810 where I reviewed, we're going to take the square root of both sides here. But we do have to remember that when I take the square root, I'm going to get 2 answers because it is quadratic. So I get x equals plus or minus the square root of negative 9, which becomes plus or minus 3i. We now have 2 real roots here, and we have 2 imaginary roots or complex roots here. I hope you all have enjoyed this short video on solving polynomials or finding roots of polynomials that can be factored or undone. We look forward to seeing you. We love you. We miss you. Go Sabres!